Good morning. Hope you all are enjoying PD today. Lovely Friday. What I'm going to do is just go through some of my big takeaways from the Denver Math Conference, from Minds on Math, and really just a lot of my personal reflection involving a lot of those conversations. So the first thing that they really opened up with the general question of how do you really teach math for understanding? And personally, it made me think about just besides giving kids problem-solving strategies, how do you really train them almost to have these conversations and engage in really good discourse and use the workshop model as a tool to really promote these thinking strategies. So they had gone through 7 thinking strategies here. I'm not just going to read them off, but really just people using background knowledge throughout the process of solving a problem. And as far as these other strategies go, I highlighted the ones that I really want to look at were the questioning and determining importance, because all too often kids are asking when are they going to need this and how can they use a lot of the knowledge that they already have and apply it. And I feel like the workshop model is a really good tool for that, and also applying these 7 strategies towards solving a problem. So I just wanted to go through the workshop example that they had done for us, which was what I would interpret as something using like arithmetic sequences, but down at the elementary level, they could even consider it just using patterns, and kind of just shows you how we all had a lot of different prior knowledge and different ways to approach a problem, and that's a lot of the ways that kids are thinking too. So they went through a mini lesson where they kind of gave us a parallel problem, something similar to what we were going to see, and then there was a huge chunk of work time where we were working individually and then pairs, and then there was a lot of reflection, a lot of that personal reflection that I feel like gets left out because you're cramming in to get so much in 1 hour that you really leave out that really important piece where kids are kind of wrapping up their thoughts in their own mind. So when they presented their mini lesson, they put the learning targets up, and then they went through this parallel problem. So something where they had introduced a problem. It gave you a minute to kind of think about a strategy that you might use, and then all of a sudden they called up some student volunteers to really model the problem situation and use an anchor chart as a reference visually for us to see their thinking strategies, but also kind of tap into what your students are thinking also. So as they're going through this problem, I was already coming up with different approaches that I might want to use. And the genius of using a parallel problem like that is a lot of those strategies I was able to actually apply them to the problem that I was working on. And that was really the next part then. They started off by giving us a bunch of independent work time. So started off by giving you choice of a problem, developing your own strategy, which that's the part that promotes the accountability, that if you just group students right away in a group of 4 or something and you got the one kid that's just doing all the work, they're obviously taking a lot more away than the other 3. So this just puts a lot more in their hands. It gets them that buy-in, and then just by giving them a smaller kind of task, they're willing to take those risks a little bit more and then break out into the next larger group. So after the first 5 minutes or so, they had us work in pairs or groups of 3. And they gave you another task to do. So with that other smaller group, we had to come up with a poster which used 3 different problem-solving strategies. So not that there's always going to be specifically 3 problem-solving strategies, but just really pushing kids to develop multiple approaches to a problem, whether it be using an equation or doing something graphically, or just even explaining to their friends and having a good in-depth conversation about something and just thinking about it in a different sense. It was really a rewarding feeling then because you're sharing different ideas. They paired us up by different grade level. So having the high school end of this, I jumped right away, like I said, to arithmetic sequences, and that kind of blew the minds of more of the kindergarten teachers that are just doing it more off drawing a picture. And then we kind of just brainstormed together and developed an equation based off the problem situation, and then presented that as a larger group then and did a giant gallery walk so that you could see what different groups were doing, see a lot of their approaches. And then I also learned a bunch from some of the different ways that other high school teachers have taught a similar unit, just based off those kind of rules or equations that were out there. So it was a huge takeaway, K-12 for one type of problem, and a lot of that really could push towards an individual unit just by thinking about the different types of approaches that students might use involving their own prior knowledge. And then at the very end, we shared out. So this is when we did a gallery walk type thing, had conversations with other groups, but then we went back to our desks and had a lot of personal reflection on, how did your learning really relate to the learning target that was up there, or that parallel problem, and a lot of the relationships between those. And I think all too often kids just want to jump for the pattern between those two things, and this really gives them that chance to do it, but at the very end of the lesson. So they're able to make that connection and really bring it all together. And I think another part that I really leave out personally is how large of a chunk this is at the end of a class that really does tie everything together, because we're so used to just trying to cram material in and nervous that you're not going to get it all in one class period, and you're going to go into the next, and then you're going to get off pace. And really just taking that last 5 or 10 minutes even just to have students individually reflect on something, or make these connections, or have conversations with peers just about the big picture of everything. And then throughout, I think the next day in the conference, they had us do some reading from the Minds on Math text. My chapter was about discourse, which is something that I feel like I can always do a ton better in the class, and it's really tough because a lot of the questions that I was bringing to them were involving getting the low-level learners to really care about math, or bring something to the table, because a lot of times the kids are so hesitant. So it's really like, how do you include those kids in your discussion, but how do you also make a question that's going to challenge your top tier student as well? This definition of discourse, I love. This came out of the book. So it involves learners making meaning of content through accountable, engaged conversations about their thinking, which again, that's really what discourse it is about to me, is getting those engaging conversations. How do you come up with questions that are really that good, that get kids to think for more than 10 seconds, come up with an answer, and then just disregard the rest of it? So throughout this chapter, and I'm not just going to read through these again, but really focus on metacognition. Again, students tapping into their own prior knowledge and putting something on paper that has relevance by giving them enough time for them to approach a task individually, come up with strategies, and then share those out. And it really does emphasize everyone's values then within the class. And I've seen this, I've modeled a couple lessons since then, trying to get better at just cutting down on the amount of content that I'm trying to get through and focus more on the quality of my questions overall. So I did an example in my pre-calc class. Amy's been working with me on a coaching cycle around the conic sections. So really at the very beginning of class, I was using another tool, Desmos, just for graphing. It's just easy feedback, instant feedback for kids to just type in equations and make their own inferences about, and in this case it was circles, but they can just really type in equations and you're getting that instant look at what the graph looks like. And I gave them a couple problems where they had to type in different forms of an equation and graph them, and then work backwards, where I gave them a graph and then they had to come up with the equation. So that was a really big jump for a lot of students. What a lot of them started doing was more of a guess and check, and some of them started diving into how the equation might relate to it. And there was a lot of prior knowledge from that. We did a bunch of talk on transformations. So a lot of kids, not just the high tier of thinker either, a lot of them were bringing in their knowledge of transformations and how, the opposite affects the x values on the inside of parentheses, and how that can move the center of your circle, and then how you really just need the radius and all of this. And it was a lot of really good individual thought that then they started pairing up with other kids in class. And then when I gave them their work time, I gave them 3 different problems involving either writing equations given 2 points, or I gave them like a center and an edge. I had them solve for area, which, that's more of your ACT type question, where they're just subtracting out different areas and again coming up with problem solving strategies. So a lot of kids were just jumping towards a lot of the things that they had done in math class, like I have the midpoint distance, Pythagorean theorem, all that stuff, and how they could apply that to that problem situation. But it was just really awesome just to say, okay, we're only going to do 3 problems in a day, and we're going to dig deep, and I'll give you a little bit of time for each one of these. And that was a huge part of it, and that's where you get better just the more you teach that type of lesson. So the first time I did it, it was all about pacing, and how do you know that you're giving them enough time, and really reading into how much time the kids need just by walking around and having conversations with them. And a huge part of that is just being flexible as well, and realizing that if you don't get through all 3, it's not the end of the world, but to really save a lot of that last 10 minutes to really get away those key takeaways. So for me, I ended up doing that. I got through the lesson with about 15 minutes left, that they could just take a look at some other parallel problems then and think about how they would approach those. And by my third block, I had a lot of kids finish in that 15 or 20 minutes that they ended up with, and they did a bunch of practice problems, and they wanted to know if they were correct, and it was awesome that they were able to use a graphing calculator tool to check their work, and also just ask and compare the results with other kids in class, which I've never really seen that from my pre-calc, where kids were just that eager to get their homework done because they knew that they had the concepts down. So that was really refreshing, and the kids enjoyed it. It was a little bit different. So I'll just wrap this up. A lot of the big takeaways that I had then at the very end of this conference, just talking about deep math, really the idea that you're not just going to pour concept after concept on a kid and you're going to, we're going to do chapter 1 today and then chapter 2. I'm going to give you a review. You're going to do a summative, and just over and over the same process just becomes boring for kids, that they're really not thinking for themselves. They're trying to just understand something, see a pattern, and then hopefully they quote, remember it the day of a test, and sometimes they forget it, and it really just takes away from their total overall understanding of it. But also, as educators, what is our role? And that's the difficult part, which is creating these challenging tasks, because planning time is tough to find, and it does take a lot of time to come up with these in-depth questions. Even though there's only a few of those questions, it takes a while to come up with something that's really going to drive your entire class. And again, that's where this quality over quantity, I feel like we hear it a bunch, but ultimately it comes down to how much time we're really given to work with each other and collaborate on coming up with really good activities. But I took a ton away from this conference. Like I said, this last chapter that I went through just on discourse was great. The other ones that they had us read, chapters 1 and 2, just more of an intro and then talking about how we can integrate some of these tools in the classroom. They were really good to read, and it was awesome to reflect with other educators from K-12 across the spectrum and really think about that vertical alignment overall of, if we can get kids to have these conversations and persevere in the elementary level, then they'll be significantly more successful being able to apply their background knowledge and problem solve as they go through high school.